Hello students, today we will solve the numericals and the reasoning questions based on capacitor and dielectrics. So the first question which we are having, in this question C1, C2, C3 and C4, they are four identical capacitors each of 10 microfarad and they are connected as shown in the figure across a battery of 500 volt. The question is saying to find, in this case, the charge stored on the four capacitors. Now, if you see the diagram carefully, C1, C2 and C3, they are connected in series and their series combination is connected in parallel to C4. So, first we will calculate the net raised capacitance of series combination. So, for series combination, the formula is 1 upon C net is 1 upon C1 plus 1 upon C2 plus 1 upon C3. So we get the value of C dash as 10 upon 3 microfarad. Now this C dash and C4 are connected in parallel. So the net capacitance of the circuit is your 40 upon 3 or 13.3 microfarad. So the first part of the question was saying calculate the net capacitance. So this is the answer of part 1. Now in the second part it is saying charge across the four capacitors. So if you see C1, C2, C3 are in series and in series the charge remains the same and potential difference is 500 volt. So we apply the formula ki Q1, Q2 and Q3 are equal and value wise will be C dash into V, means 10 upon 3 into 500 and convert from microcoulomb to coulomb. So we get the answer as 1.7 into 10 power minus 3 coulomb. And now for C4, it is C4 into V. So we get Q4 as 5 into 10 power minus 3 coulomb. Now next question is saying we are having three capacitors C1, C2 and C3 connected between point A and B. At point A the potential is 90 volt and point B is earth. So you know the potential of earth is always 0. So we can say potential difference between A and B in this case is 90 volt. The question is saying calculate the potential difference across the plates of capacitor C2. Now you know total potential difference is given 90. Net capacitance we can calculate कि C1, C2, C3 are in series. So value wise we get on solving 1 upon C, 1 upon C1 plus 1 upon C2 plus 1 upon C3. So when we calculate the net capacitance is 20 upon 3 microfarad. And you know on series combination the charge on the plates remains the same. So we get value wise ki total potential difference is 90 volt. Capacitance we know, so we apply the formula Q is CV. So on solving we get कि charge between the plates will be 6 into 10 power minus 4 coulomb for each capacitor. So now we apply it for second capacitor. The Q is CV. So that way we get Q is C2 into V2 and on solving we get 20 volt. Now next question is saying we are having two capacitors X and Y and they are connected in series to a source of 12 volt. Now X is having, means dimension wise X and Y are identical, means their area of plates is same and the plate separation is same for the two capacitors, but between the plates X is having air and Y is having a dielectric medium of K is equals to 4. And in this case it is given that net capacitance of this combination is 4 microfarad. So we have to calculate the values of X and Y, means the capacitance of X and Y. Second part, potential difference between the plates of X and Y and the ratio of energy stored in X and Y. So you know कि say for example we are taking first capacitor epsilon naught A upon D. Second one, dimension wise everything is same, only we have to multiply it by the dielectric constant. So that way we can say that Cy will be 4 times of Cx. Now Cx and Y are in series. The net capacitance we can calculate 1 upon Cx plus 1 upon Cy is 1 upon C net, and it is given in the question that net capacitance is 4 microfarad. So on solving and substituting Cy is 4 times Cx, we get the value of Cx as 5 microfarad and Cy as 20 microfarad. Now second part, you know in series combination the charge remains the same. So we get the value Q is Cv. So we get the value of charge as 48 into 10 power minus 6 coulomb. So now we apply the simple formula कि Q is Cv, and by applying that formula we get potential difference between the plates of capacitor X is 9.6 volt and for capacitor Y is 2.4 volt. Now third part is saying ratio of energy. You know whenever we are connecting the capacitors in series and we have to compare the ratio, then the formula is Q square by 2C, because in series combination the charge remains the same. So we are applying that formula only and we get ratio of energy will be Ux upon Uy will be Cy upon Cx, means 4:1. Next question. It is saying if we are having two capacitors C1 and C2. C1 is 8 microfarad capacitor and it is charged by a source of 120 volt. C2 is 4 microfarad capacitor but it is uncharged. Now we connect C1 and C2 as shown in the figure. So initially C1 is charged and C2 is uncharged. As soon as we switch on the circuit, then you know that C1 will start transferring the charge to C2. So in that case the question is saying find the net potential difference of the combination and the initial and final energy stored in the combination. So you know initial charge, you know C1V. So we get the value as 8 into 10 power minus 6 into 120. That way we get 96 into 10 power minus 6 coulomb. Now capacitors, whenever we are having one charge and one uncharged capacitor, then the combination is always parallel. So net capacitance is C1 plus C2 means 12 microfarad. So we get the Q value, you know, the overall charge, right? In this case, the final is same. So we get final potential will be the charge because that remains the same in the combination. That is the charge on first capacitor upon C net. So on solving, we get 80 volts. Now initial energy, you know, only the capacitor 1 was charged. The value is half C1 into V naught square. It means half into 8 into 10 power minus 6 into 120 ka whole square. So we get 5.76 into 10 power minus 2. And for final one, you know half C dash V dash square. C dash is 12 microfarad and V dash is 80. So we get 3.84 into 10 power minus 2 joules. And the difference of energy appears in the form of heat during the discharging of first capacitor, or you can say transferring of charge from one capacitor to another. Next question we are saying if 1, 2, 3, 4 capacitors are connected as shown in the figure. The question is saying find the net capacitance. If you see between the A and B only we have to calculate the net capacitance. But if you see the diagram carefully, first plate of C1 is connected by this connecting wire and that is coming to point D. At that point, the second plate of second capacitor and first plate of third is coming. It means C1, C2 and C3 all are having one plate connected at point D. And same way if you see, and the second point is connected between C. Because the second plate of first one, and in this case the first plate of second and the third plate of third capacitor, second plate, they are coming by this connecting wire to this point C. So we can say between C and D, the capacitor 1, 2 and 3 are connected in parallel and the parallel combination is connected in series to the C4. And so we get the value C dash is C1 plus C2 plus C3 means 10 microfarad. And now C dash and C4 are connected in parallel, in series, sorry. So we get the value on solving C is 5 microfarad, means net capacitance of the circuit is 5 microfarad. Now remaining numericals you will take in next video.